Assalamualaikum and very good day to my beloved panels. My name is Hafiz Azamuddin bin Abdul Manan from the Faculty of Mechanical and Manufacturing Engineering Technology. And today I'm about to present my Bachelor Degree Project 1, which given title Comparison Study of Microstructural Evolution of AZMUDDIN Magnesium Alloy via Helical Channel. My supervisor for this project is TS Dr. HANIZAM bin HASHIM. The outline for this presentation will begin with the introduction, that content of background of study, problem statement, objective and scope of study, and we continue with literature review, methodology, and lastly with the expected result. So let's begin with the background of this study. The development of wide scale of structural and useful materials for energy production and transportation have been propelled by a growth demand for lightweight, energy efficient, and environmentally pleasant engineering practices. Magnesium alloy have been used for lightweight structural system in response to this challenge. The fundamental reason for magnesium appear in the automotive sector, where lightweight structures are required, is its lightness. According to Davis et al., when compared to metallic structures such as aluminium and iron, magnesium has substantially lower density than these metals. A semi-solid process for non-dendritic structure was prepared for develop high-performance semi-solid magnesium alloy. Several research processes have been done by researchers to study the microstructure. However, the current commercial magnesium alloys low mechanical structure and creep endurance limit their wide usage as functional and structural components, specifically in the automotive industries. As a result, developing a magnesium alloy that meets the requirements for intensity, ductileness, weakness, and other properties is important. Thus, this research study takes initiative to develop new process for non-dendritic structure. The microstructure is then compared with direct casting by evaluate them using metallography method such as hardness test and tensile test. Next is problem statement. Lightweight structures are in high demand in automotive industry because it can reduce the fuel consumption from engine and reduce carbon dioxide emission. To achieve high engine efficiency in automotive, a new semi-solid processing method for preparation of formation non-dendritic structure is needed. A helical channel will be designed to improve the AZMUDDIN magnesium alloy mechanical structure and properties and provide a reasonable study of lightweight magnesium alloy. So then, the objective of this project is firstly to design a new helical channel for non-dendritic structure of magnesium alloy production. Second, to compare the microstructure of AZMUDDIN magnesium alloy via direct casting and helical channel. The third, to establish the solidity and hardness of the alloys via direct casting and helical channel. The scope of this research is an extension of the parameter that should be explored and focused on. Therefore, the study is specified to focus on the design a new non-dendritic feedstock production, which is helical channel. The optimum parameter of pouring material into the helical channel need to be observed. The mechanical properties of cast magnesium alloy will going through metallographic technique analysis. The data collection of microstructural evolution of cast magnesium alloy will be conducted between direct casting and helical channel in order to compare their mechanical properties. So the next part we talk about the literature review, which I will explain about all discoveries obtained from many literature reviews, which may come from the internet, papers, articles and books about the issue related to this research. Magnesium alloy has the greatest possibility for improving fuel efficiency by lower the vehicle weight. It is gaining popularity due to its low density or high pitch specialized strength, which allows for significant weight saving in the automotive and transportation industries. This is the most fundamental reason for magnesium increased importance in structure application. This metals alloy gives strength while reducing weight without significantly increasing cost. As a result, various magnesium alloy have been manufactured by using several processes of semi-solid for microstructure evolution. This process alters the characteristic of magnesium alloy, allowing it to be used on an industrial basis. As shown in the slide are several studies that are found related to this project. The first one is evolution of non-dendritic microstructure of semi-solid alloy prepared by shearing cooling roll process from the author Chuncheng Wang, Wenlun Guan, Jingyu Wang. From their findings, the dendritic arm fracture and form aqueous or spheroidal grains when sheared and stirred in a semi-solid slurry together with high volume proportion of solid. Second is semi-solid microstructure evolution of alloy during partial remelting from the author C.J. Davidson and M.J. Cooper. In their finding, a more globular microstructure is produced via less significant scarce particle size and extended isothermal holding time. Next, mechanical response and microstructure evolution of repetitive upstanding extrusion process AZ61 magnesium alloy in semi-solid compression by the author Yangzhu Jungjing Zhang. In their finding, globular solid particles and liquid sheet compensate the thixotropic microstructure. A significant quantity of small fluid drops emerge with the solid fragments which can be seen. Lastly, microstructure and mechanical properties evolution of magnesium AZ61 alloy processed through a combination of extrusion and thermochemical processes. From the author El Morsi and Ismail, they found out the combination produced a grain refining effect. The microstructure indicates a coarser particle than the extruded individual after the first pass of 20% thickness reduction. This paper's research design is given in a flowchart, with the project organized in a flowchart to make it more structured and comprehensible. In general, the flowchart displays how the project should be carried out in order to meet the research study's goal. For the experiment, we use magnesium alloy as 91 and will going through casting process, which are direct casting and helical channel. For the direct casting, we use permanent mold, and for the helical channel, a new design need to be created by using polystyrene for the pattern. After that, molten alloy AZ91 will then pour into these two methods. Next, the specimen will undergo cutting process and then will tested for their hardness by using Rockwell hardness test and micro hardness test. For the microstructure analysis, the specimen will undergo microscope analysis, and lastly, the result analysis will be taken. The raw material used in this research is magnesium alloy AZ91. The chemical composition of AZ91 magnesium alloy used in this study is present in table below. To conduct experiments, the magnesium alloy was melted. Then the molten alloy was allowed to cool down to the pouring temperature and was then poured into the helical channel with length of 15 cm maximum. For the microstructure characterization, specimen will be studied using optical microscopy or specific SEM technique. A final mechanical polish is required. Mechanical grinding and polishing is the removal of material from specimen using progressively finer grinding paper or polishing chemicals. Diamond polishing abrasives are often available in liquid suspension in various sizes. Specimen is held in one orientation to keep the scratch in a regular direction. The second is etching. Metallography etching is accomplished through immersion in a suitable chemical solution, which results in selective corrosion. Next, we move to the hardness test. Rockwell hardness test will be applied to the specimen by assess a specimen resistant to indentation when a consistent stress is applied for a short period of time. Ball intender is the intender used in the Rockwell hardness test. For micro hardness, light loads are intended with a diamond indenter, which is then measured and converted to a hardness value. Testing is done with a square-based pyramid-shaped diamond. Last but not least, I'm about to talk about the expected result. In this present experiment, great stability could be achieved in mechanical properties of AZ91 microstructure by using new design of helical channel compared to the direct casting process. The design of helical channel determines the microstructural evolution of AZ91 magnesium alloy. The suggested method contributes to a deeper knowledge of the formation and evolution of non-dendritic structure in magnesium alloy. This helical channel process is expected to be suitable method for feedstock production that require low cost production.